Hello and welcome to the final video of 4 on representations of data on representations of data for the stats portion of the Year 12 A-level maths course. So we've had a look at box plots, we've seen histograms and cumulative frequency diagrams. This last section is going to focus on how to best compare different distributions from one to the other. So before we have a look at that, there are some warm-up questions you may have guessed at. So here they are. So if you could have a go at these independently by pausing the video and trying on your own to see how you get on. Press play when you've done them to compare your answers against mine and make any corrections if you need to, or hopefully no corrections at all. So let's have a look now at question 1. So question 1, we've got this table showing the lengths in minutes of 40 films. We need to estimate the median film length. This is one of these interpolation questions. So what we need to do here is to think about where the median would lie. So there's 40 films. The median, we just divide the 40 by 2. It's continuous data, so we don't need to do the adding 1 business. We just do 40 divided by 2, which is obviously 20. And that tells us that the median will be the 20th value. So now what we need to do is we need to add in the boundaries on these class intervals and also do a cumulative frequency running total. And so this boundary here from 60 to 80, the lower bound is 60. The upper bound is 80, which is also the lower bound of the next interval. Then we have 100, 120, and the final one here, the upper bound, is 180. We now do similar for the cumulative frequency. So always start the cumulative frequency from 0. I'll get that in a different colour actually. Let's go for a nice red. 0 plus 8, obviously 8. 8 plus 12 is 20. 20 plus 6 is 26. And lastly, 26 plus 14 takes us up to the total of 40. So now here, we can see that the median is actually going to be right on the boundary of the 80 to 100 interval and the 100 to 120 interval. So using intuition, you might be thinking, well, is the median 100? It actually would be, the estimate of it at least. But I'm going to show you this using the formula which we've used before, in case you're not sure or can't quite see why the median would be 100. So what we'd do is we'd keep going down these red figures until we get to a value which is at least the median. So the first value, which is at least 20, is obviously 20. And so we could argue here that the median will be immediately where this next interval begins. So it's not even the 21st, it's not the first one in this boundary, it's going to be the 0th one. Or, looking differently, you could see it as the median is going to be the very last one in this boundary from 80 to 100. So the median is going to be right at the end of this interval, okay, because the 20th value is going to be the 12th one in the class interval from 80 to 100. So with a little bit of thought, we can actually see that the median is going to be 100 minutes. Because the median is actually one of these cumulative frequency totals. It's right on the boundary between 100 and 100, so it stands to reason the median is going to be 100 itself. Next up, we're asked to find an estimate of the interquartile range. So again, we can see here, if there's 40 films, we can work out what value would be the lower quartile by simply dividing by 4. So 40 divided by 4 is 10. So therefore the lower quartile, Q1, is going to be the 10th value. So whereabouts is the 10th value going to be? So we'll look for the first number here, which is at least 10, which is 8. So it's going to be in between these two numbers. 10 is in between 8 and 20. So that tells us that the lower quartile is going to be in the interval from 80 to 100. So what we need to think about now is which number value would it be? Well, this interval starts after the 8th value. If we're after the 10th value in the whole data set, this one starts after the 8th, then the 10th value will be the second in this one. 10 take 8 is 2. So therefore we can say that Q1 is going to be the second value out of a total of 12 in this interval. So we can just write this in like so, and then we can begin to formulate how to solve it. So next we can say that Q1, therefore, we're going to start where this interval starts. So let's start at 80. We're now going to add in this fraction, 2 out of 12, of the width of this class. So plus 2/12 of, from 80 to 100, that's 20. So let's just calculate this quickly. So 80 plus 2/12, which I know is 1/6, but I'm just leaving the numbers as they were found. 2/12 of 20, 83.3 recurring. Now we're going to round to 3 significant figures at the end, but for now I'm not going to round it. So that's about 83.33 recurring minutes. We now need to think about where the upper quartile would lie. The upper quartile is 3/4 of the way through the data set. So we need to work out 3/4 of 40, which is obviously 30. So that tells us that the upper quartile, Q3, is going to be the 30th value. So again, in a similar way, we need to find out where the 30th value would lie. So we have a look at the cumulative frequency numbers in red, and we go to the first value, which is at least 30, which is obviously 40. So that tells us that the 30th value is going to be in this interval from 120 to 180. Another way of thinking about that is that 30 is in between 26 and 40, and 26 and 40 are the boundaries of this interval. And so we know that the 30th value is going to be somewhere in the interval from 120 to 180. Next, we need to consider whereabouts the 30th would be in relation to this interval. Well, this interval starts immediately after the 26th value. We're wanting the 30th value. 30 minus 26 is 4. So this tells us that the 30th value is going to be the 4th value in this interval. So Q3 is going to be the 4th value, so it's the 4th out of these 14 values. So that's going to be a fraction we're going to be using in a moment. So it's the 4th one out of 14 in this interval. And we can now estimate what Q3 is. So Q3 we begin where the interval begins. So we're going to begin at 120. We're going to add in this fraction, 4 out of 14, multiplied by the width of this class interval. From 120 to 180, that's a class width of 60. So we're going to add on 4/14 of 60. So let's just calculate this. So 120 plus 4/14 of 60. And that gives us 137.1428. So let's call it 137.143. That's more significant figures than we need. We'll round to 3 significant figures at the end. Never round too soon. Only round at the end. So 137.143. I'm rounding, I suppose, but I'm rounding to much more accuracy than what I intend to round to. So no rounding error will creep in. So 137.143. Now we can work out the interquartile range. So the interquartile range is the upper quartile, Q3, minus the lower quartile, which is Q1. So that's going to be Q3, which is 137.143, minus the lower quartile, which we got was 83.3 recurring. So when we work this out, we've got our answer. So this number here, minus 83.3 recurring. So we get 53.8 minutes to 3 significant figures. And that's our final estimate for the interquartile range. Question 3 of the warm-up is very similar to question 2. So percentiles work very similar to quartiles. For question 3, we need to find an estimate of the 10th to 90th interpercentile range. So this comes in 2 different parts. So first thing we need to do is to find the 10th percentile, then the 90th percentile, then we do the 90th percentile minus the 10th percentile. So first of all we need to do here to find the 10th percentile is we need to find 10% of the total frequency. So the total frequency is 40. It says here there's 40 films. So 10% of 40 is obviously 4. Use your calculator if you're half asleep. Anyway, that tells us that the 10th percentile is going to be the 4th value. So it's going to be in this first interval. This first interval has 8 values in total, and so the 10th percentile is going to be the 4th out of 8 in this first interval. So it's going to be the 4th out of 8 in the first interval, which is from 60 to 80. So we can now estimate the 10th percentile. So P10, we start where the interval starts, so start at 60. We're now going to add on this fraction, 4th out of 8, which is essentially halfway into this interval. So plus 4 out of 8, which I know is half, but I'm leaving it unsimplified so you can see where the numbers have come from in the first place. So plus 4/8 of this width. So from 60 to 80 is a class width of 20. So 60 plus half of 20 essentially, that's going to be 70 minutes. So P10 we've estimated to be 70 minutes. Now to work out the 90th percentile. So work out 90% of 40 now. So 90% of 40 would be 36. That therefore shows that the 90th percentile, which we write as P subscript 90, would be the 36th value. So the 36th value is going to be in the last class interval. This last class interval starts after the 26th value. If we want the 36th value, that's another 10 on top of 26. So this one here, the 36th value, is going to be the 10th value out of a total of 14 in the last interval. And that last interval is from 120 to 180. So therefore, the 90th percentile, we start where this interval starts. So start at 120. And again, we're going to add on this fraction, 10th out of 14, of the width of the interval it happens to be in. So 10th out of 14 of 60. So again, if we just quickly calculate this one, so 120 plus 10/14 of 60, that gives us 162.857. 162.857. So now we've got estimates of P10 and P90, we can work out the 10th to 90th interpercentile range. So now, for 10th to 90th interpercentile range, that's going to be P90 minus P10. So P90 is 162.857-ish. Now we're going to minus from that whatever P10 was, and we estimated P10 was 70. So 162.857 minus 70, so if we just knock off 70 from what our calculator stored last time, we can see here we get about 92.923 sig figs. So the 10th to 90th interpercentile range is going to be 92.9 minutes. And that's given to 3 significant figures. Let's now have a look at the final warm-up question, question number 4. So for number 4, we have to find an estimate of the mean film length. Now I want to really push hard for ClassWiz for this one. So if you can do it on a ClassWiz, you may as well do. It's just quicker, it's safer in terms of minimizing the chance of making any mistakes, and it would be daft not to use a ClassWiz, to be honest, when you've got such a powerful tool in your hands in the examination. However, this is continuous grouped data, so we're not told any exact values. So whether you were doing this manually or even not, what you'd need to do would be to calculate the midpoints of these groups. So I'm just going to manually add in another column in between the length and the frequencies. I'm just going to call this MP, which is my lazy way of saying midpoints. I don't want that actually. I've got arrows in between, so there, that's what I wanted. So I'm just going to say this is NP for midpoints, which I'm now going to add in manually. So from 60 to 80, that midpoint is going to be 70. Halfway between 80 and 100 is 90. The middle of 100 and 120 is 110. And these two, if you add these two together and divide it by 2, which is another way of finding the midpoint directly, that midpoint is going to be 150. So using the class whiz, what we're going to do next is get into the right mode first of all. So you need to remember how to get into the correct mode. I'm going to show you it on the big screen as well, so that you can see what I'm typing in case it's unclear on your small phone, for example. So we press Menu, we scroll down until we see Statistics, option 6, press equals. We want a one variable calculation. The only variable here is times, so press 1 for one variable. And now you might see this where you've only got one column and nowhere to input your frequencies. To turn on the frequency column, what we do is we press Shift and then Menu. We now scroll down until we can see option 3 for statistics. So press option 3 and then press 1 to turn this frequency column option on. Now for the X's, we type in the midpoints. For the frequencies, self-explanatory, we just type in the frequencies. So for the first X is 70, next midpoint is 90, next midpoint was 110, and the final midpoint is 150. We now scroll back up and type in the corresponding frequencies. So where we had a midpoint of 70, the frequency was 8. The next frequency is 12, and 6, and finally 14. Now we've input all our data, we press AC, option OPTN, and then we select one variable calculation. And so we have here an estimate of the mean film length, which is X bar. And so an estimate of the mean film length is 110 minutes. Try and check as well if that answer makes sense. 110 is nearly 2 hours, so would an average film length be an hour and 50? I think it would be, potentially. You could have longer films like Lord of the Rings and things, and then shorter films which might be animations. And as well, 110 is in the range of this table. So that's just a quick double check of just ensuring you've not typed in something completely wrong by mistake. 110 seems reasonable. It's within this range here, so let's just trust ourselves. 110, we've used the calculator correctly. Part B, it says find an estimate for the variance of the lengths of these films. And so how do you find variance on this display? Well, variance is the square of the standard deviation. So standard deviation is this symbol here, sigma x. The standard deviation is 31.6 to 3 significant figures. The variance is this symbol here, sigma squared. So the variance, at least the estimate of it, is 1000. So we're going to type in sigma squared. The variance is about 1000. You want to maybe include units, you can do. I don't think it's going to be too critical, but the units for variance is the units of the data squared. Squared minutes doesn't make any sense. You could probably leave it as 1000, but if you wanted to include units, it's minutes squared. And part C says, hence, find an estimate for the standard deviation of the film's durations. Well, we just square root the variance, but the calculator does that for us anyway. So the standard deviation is 31.6 to 3 significant figures. Now, you might notice here, in the past I've shown you two ways, both manually and just using the class whiz quickly. I'm fading out doing it manually, although, however, if you have done this using the formulas and estimates of the mean and done it the slower manual way, that's absolutely fine, but I'd like you to just check your final figures against these. I'm not going to show you at this stage how to do it the manual way. If you want to, that's fine, but as I say, I'm going to push as the year goes on the class whiz more and more. That's warm-up completed, so now let's have a look at the main body of the lesson. So, comparing data. I've mentioned this before, but it needs mentioning again. So, when comparing data, always attempt to comment on a measure of location, which is the first thing, and a measure of spread. You need to comment on those two things all the time, unless a question says. So there's two main ways to do this. So the first way is to compare the medians and the interquartile ranges, or alternatively, you might want to compare the means and the standard deviations. And again, like I mentioned before, but it's worth mentioning again, just make a note, you can't mix and match these measures. So in other words, what I'm trying to say here is you can't compare the medians with the standard deviations, and you can't compare the means with the interquartile ranges. That's just a mishmash of different measures. So keep these as families. So medians and interquartile ranges are one family, means and standard deviations are another family. So keep them separate, stick to one or the other, depending on the context of the question and the data you've been given. So let's have a look at some worked examples. So first worked example here, you've got two Year 12 maths groups, 12A and 12B, and they are having an end of term examination. So they've done an end of term exam. So each student's percentage score, given as X, is recorded, and summary statistics for the percentage scores are shown in the table. And so if you notice here, we're only given the sum of the scores and the sum of the squares of the scores for both classes. So this is one where you can't just bash in on the class whiz. So these summary statistics are a way the examiner sometimes uses to try and catch people out. Regardless, let's have a look and do this together carefully. So part A, calculate the mean and standard deviation for each group. Formulas you need to know, and are given in fact in the formula booklet, are these. So you're given essentially these anyway. So the variance and standard deviation are given by these formulas. So we can process which bits we have and then just input these values in the table into these formulas here. So this listed data is going to be the easiest thing to use here. So if I just hone in at the listed data, so I'm just looking here for now. So we're told we need to know about sigma x squared. Okay, so this is for standard deviation and the variance. So we're wanting standard deviation, so actually put that there. So we know those, so that's good. What else are we told? To work out the standard deviation from this, we need sigma x. Well, that's great, because we've been told this as well. Sigma x is this column here, and here, n and sigma f are one and the same thing. So another way of thinking of n is it's the sum of all frequencies. If n is just the total number of values, that's the same as saying it's the sum of all frequencies. So you need to know that this one and the other are one and the same thing. So I've been told these as well in this column here. So what we need to do next is calculate the mean. So the mean, this essentially is the mean. It's just the total of the x values divided by the total of the frequencies, which is given as n. So we need to do this for each group. So let's first of all work out the mean for 12A. So that's going to be sigma x for 12A divided by n for 12A. So just looking at 12A, sigma x is 1105. Divide it by n, which is 20. And that'll give us an estimate of the mean for 12A. So 1105 divided by 20, 55.25 minutes. So round it to 3 sig figs, or suppose you could leave it like this because it's not a very long awkward decimal. Either way, I'm going to give it to 1 decimal place or 3 sig figs. 55.3 minutes. Check if the answer makes sense. 55 minutes, about an hour to do an exam. Is that normal? Is that typical? I'd say it is. If you get an answer of 553 minutes, try and just have a second think to yourself, is that going to be reasonable? Is that realistic? No, it wouldn't be. So always check if your answer makes sense in context of the question, if you can do. Now we need to work out the mean for 12b. So the mean for 12b, again using the same formula. So for 12b, it's 1149 divided by 26 and that gives us 44.2 minutes. So 12b did it quite a bit quicker, so 44.2 minutes. Next, we need to work out the standard deviations for each class. So let's do this first of all for 12a. Now for 12a, I'm going to use the formula as it's given. I'm not going to use the rounded values for the mean. So we're going to do the sum of x squared, which is 66455, all over n, which is 20. I'm going to minus sum of x, which is 1105, apologies, so I've just realised something. These aren't minutes, these are percentages. How silly. Sorry. So I'm going to change these to percentages. My mistake. So 1105 over 20 all squared. So if we just input this, so 66455 over 20 minus, in brackets, 1105. If you notice here, I'm using the exact way of calculating the mean, not the rounded mean, to avoid any rounding error. So minus that squared, that gives us 16.4 minutes. Sorry, 16.4%. Keep wanting to say minutes for some reason. And now we can do the same for 12b. So for 12b, the sum of x squared for 12b is 65935 all over 26, then minus 1149 over 26 all squared. So let's see what this one gives us. So square root of 65935 for 26 minus 1149 over 26 all squared. And that gives us 24.1%. 24.1%, yes. And that again is to 3 sig figs. So we've got 16.4% and 24.1% for 12a and 12b respectively for the standard deviations. And the means, 55.3% for 12a 44.2% for 12B. Let's now have a look at part B of this question. So part B, make comparisons between the distributions. Let's just remind ourselves of what we had from part A. That's what we had from part A. So we can compare the means and the standard deviations in context of this question. So to make a comparison, make reference to the means and standard deviations. So something like this would suffice. So the mean percentage score is higher for class 12A than it is for class 12B. 55.3% is higher than 44.2%, obviously. Whereas the spread of the scores, because standard deviation is a measure of spread, it was greater for class 12B, because obviously 24.1% is greater than 16.4%. Let's have a look now at a second worked example 2. We've got box plots here showing the distributions of blood glucose levels in millimoles per litre of a random sample of males and females. Again, we need to compare the distributions. If we've got box plots, the two main things we can compare, because we can see them clearly, are the medians, these lines here, and the interquartile ranges, which is comparing the lengths of each bar respectively. So first of all, let's compare the medians. So for the males, the median is 3, as you can see here, and the interquartile range, this one would be 4.1, and this value here is 2.6. 4.1 take 2.6. For the males, the interquartile range is 1.5. We now do the same for the females. So the median, this line here, comes down at 3.8, and the interquartile range, this vertical line is halfway between 4.6 and 4.8, so it's 4.7, and this one here is at 3.5. 4.7 minus 3.5 is 1.2. Now we've got the medians and interquartile ranges for the males and females. We can now compare the medians for the males and females and the interquartile ranges for the males and females. So you might want to write something along these lines to make a valid comparison of these two measures. So the blood glucose levels for the females tended to be higher than for the levels for the males. That's just making reference to the median being higher. So you can make a general statement. If the median's higher, you can say that the blood glucose levels for the females tended to be higher on average, as it were. Median is a measure of average. And then make reference to the spread, which is to do with the interquartile range. So then say, and the spread of blood glucose levels was greater for the males. That's because the male interquartile range is greater than the female interquartile range. Finally, worked example 3, comparing cumulative frequency distributions. So we've got a cumulative frequency diagram showing the distribution of the average speeds of 282 cars on motorway A and 256 cars on motorway B. We're asked to compare these distributions. So this is a bit more work, but it's not too tasking if you just take some care. So first of all, let's have a look how to do this. So motorway A, I'm just going to highlight in red. Motorway A has 282 cars. Cumulative frequency links to box plots, which links to medians and interquartile ranges. So scrap any idea of trying to calculate a mean or standard deviation. You need to read off the quartiles. So we need to work out Q1, Q2 and Q3. So 282 cars. To work out the lower quartile, work out a quarter of 282, which is 70.5. So Q1 is a 70.5th value. So find roughly where 70.5 would be. We can't be too accurate because the graph is very small. So we read along and go down until we get to the curve for motorway A. So we'd find something like this. And so as you can see, the speed here is going to be about 61 miles per hour, estimated. Next, the median. So what's half of 282? Half of 282 is 141. So Q2 is 141st value. So again, read off and along at 141 and go down to get an estimate of the speed. So based on what I've got here, I'd say that's about 66 miles per hour. Finally, to work out the upper quartile, we do 3/4 of 282. 3/4 of 282 is 211.5, which tells us therefore that the upper quartile is the 211.5th value. So we find this here, read off and along to get the estimate of the speed at the upper quartile. So doing it here, I get about 72 miles per hour. So now for motorway A, we've got the median and we can calculate the interquartile range. So for motorway A, median 66, interquartile range of speeds is 72 take 61, which is 11. We can now do the same for motorway B. So motorway B, I'm going to do in blue. We've got 256 cars. So to work out the lower quartile, we work out 1/4 of 256. 1/4 of 256 is 64. So to work out the lower quartile, we read off at the 64th value, which is here. So looking at this one, it seems to be about 56 miles per hour. So the lower quartile for motorway B is 56 miles per hour. To work out the median, work out what half of 256 is, which is 128. Therefore the median is 128th value. So to get the estimate for that one, we go to 128, read along and down, like this, and then we get an estimate of about 63-ish, I believe. Maybe 62, it's close, it's between 60 and 63, so I've gone for 62. Almost 63, but probably close to 62. Again, it's an estimate, so don't get too caught up about getting a microscope out and measuring within a nanometer. Just do it as close as you can. To work out the upper quartile, we need to work out what 3/4 of 256 is. 3/4 of 256 is 192, so the upper quartile for this one is the 192nd value. So we go to 192, we should be here, read along and down, and we get here, that looks to be between 68 and 70, that looks about 69 to me. Between 68 and 69, I've gone for 69 miles per hour. So we've now got the data for motorway B. For motorway B, it's 62 miles per hour, median, and interquartile range is 13. We can now compare the medians for each motorway and the interquartile ranges for each motorway with something like this. So in this green box, we could say something like cars tended to travel faster on motorway A because it's got a higher median, and the spread of speeds was greater on motorway B because it had a greater interquartile range. It's now over to you to try some of these yourselves. So in the book, exercise 3A, page 53, try question 1, 2, 3 and 4 to give yourself a grounding on these. If you get stuck, use the back of the book to check your answers. If you've made a mistake, try and work out where you've gone wrong, or ask a peer, someone you sat next to, a classmate. If you're still stuck, obviously ask me. This is what I'm here for. Ask me in class or send me an email or leave a comment in the comment section. Thanks again for watching the video. Please do subscribe and hope to see and hear from you all soon. Bye for now and take care.